Okay, let's dive into this. Welcome back to The Explainer. Today, we are tackling a massive, systemic challenge sitting right at the bleeding edge of technology and education. We're going to be exploring the genuinely groundbreaking work of Dr. Kurt Hewlett. We're unpacking his revolutionary theories on AI cognitive architectures, and, this is the crazy part, we're looking at their incredibly high-stakes application in the world of special education. It's this fascinating intersection where quantum-level mathematical theory slams right into the very real, legally binding realities of the everyday classroom.
Here's our roadmap for the explainer today. We'll start with the paradigm crisis, then look at the Opus Omega architecture, high stakes in special ed, building the IEP Companion, the SPEDster ecosystem, and finally, forging the future mind. Let's get right to it. Section 1. The paradigm crisis, beyond the transformer. If you're an educator or a developer, you have almost certainly banged your head against the wall asking this core question: why does making AI bigger fail to stop hallucinations? Seriously, why doesn't just throwing more parameters at the problem fix it? Well, Dr. Hewlett argues it's actually because current architectures violate what he calls the cognitive persistence theorem. In short, current AI operates in temporal cognitive isolation. Every single inference exists in its own closed, isolated logical universe. Because it can't maintain causal relationships across time, as the problem gets more complex, genuine understanding mathematically drops to zero. And that brings us to a massive mathematical roadblock, the semantic grounding paradox. Current transformer models, you see, optimize over token distributions in syntactic space. That's really just a fancy way of saying they're only looking at how often words appear next to each other. It's literally like memorizing a foreign language dictionary without ever learning how to actually hold a conversation. Meaning, true meaning, lives in semantic space, which is mathematically completely orthogonal to what these models do. So scaling up parameters doesn't create understanding, it just creates incredibly sophisticated meaning simulators. Moving on to Section 2, the Opus Omega architecture, moving to cognitive partnership. Now, this brilliantly illustrates the leap in logic we're dealing with. Current AI is essentially trapped in a three-dimensional cognitive space. It's just input, processing, and output. It fundamentally cannot support self-reflection. But Dr. Hewlett's Opus Omega 3000 framework operates in an 11-dimensional space. It introduces what he calls hyperstatic reasoning, which is the ability to hold past, present, and future reasoning states all simultaneously. It acts a lot like quantum cognitive superposition, exploring multiple contradictory paths without committing to one until the absolute best solution emerges. So it's not just blindly generating text, it's recursively validating its own logic at every single step along the way. Which leads us to Section 3, high stakes in special ed, when AI fails in the real world. When you point a generic LLM at special education data, well, the results are pretty much disastrous. Look at the clinical risks involved here. Generic AI completely ignores things like the standard error of measurement. It hallucinates these deeply meaningful narratives out of totally normal, everyday subtest scatter. And it'll happily average together completely distinct cognitive domains, which totally blurs crucial diagnostic details. In special education, an AI doing this isn't just, making a harmless typo. It is actively risking IDEA due process lawsuits by generating legally indefensible goals. So the crucial point you have to take away here is this: statistical association is absolutely not clinical validity. An LLM might know that the word dyslexia often shows up near the phrase extended time, so it casually recommends extended time. It just defaults to the biases of its training corpus. But a student's actual clinical evaluation might not support that at all. Conflating basic pattern matching with true clinical judgment in an IEP, that is a massive, massive legal liability for school districts. Let's look at the solution in Section 4, building the IEP Companion, architectural bounds and psychometrics. I absolutely love this quote from Dr. Hewlett because it perfectly captures the fix. The IEP Companion software doesn't just kindly ask the AI to be accurate through some clever prompt engineering. Prompts are just guidelines, and they can easily be overridden by the sheer weight of the model's training data. Instead, the IEP Companion structurally removes the possibility of fabrication through a bounded data architecture. Think of it like a bank vault. The AI physically cannot generate a score statement without the underlying data schema actually being present inside the vault. No data, no output. Period. Here's exactly how that progression works under the hood. First up, structured data extraction pulls the numbers and preserves their strict psychometric context. Second, we use domain isolation.
You see, there isn't just one giant AI brain reading everything. There are 17 distinct bounded agents, and the reading agent literally cannot see the math scores unless the human evaluator linked them. Third, goal calibration sets targets using published growth norms, which ensures absolute compliance with the Supreme Court's and Drew F standards. All told, the output runs through 41 distinct idea compliance checkpoints before a document is ever delivered. That, right there, is how you guarantee legal defensibility.
Section 5. The SPEDster Ecosystem, Scaling the Solution. Now, wrap your head around this 95% figure. The sheer scale of efficiency here is just staggering. By deploying this architecturally bounded AI, the SPEDster system creates a massive 95% reduction in IEP writing time for educators. But, and this is key, it doesn't do this by cutting corners. It simultaneously enforces 100% idea-aligned procedural and substantive compliance.
And we're not just talking about theory anymore. This entire ecosystem, which includes the IEP Companion software, the H-Theory specially designed instruction curriculum, and expert training through SPEDster U, is currently serving over 30,000 students nationwide. This is exactly how you take lofty 11-dimensional quantum cognitive math and pull it all the way down to undeniable real-world value that is legitimately changing teachers' and students' lives every single day.
Finally, Section 6, Forging the Future Mind, Human-AI Symbiosis.
Because, the ultimate goal here isn't just to write better paperwork for the adults, it's to build systems that act as true cognitive partners for human learners. The Thinking Forge K-12 curriculum, which is rooted in the Hewlett-Opus framework, trains students to process complexity, to challenge their own assumptions, and to use data ethically. It beautifully integrates math, science, and humanities to teach our kids how to safely and effectively operate alongside these incredibly advanced technologies in what is rapidly becoming a post-AI society. I want to leave you with this final, somewhat provocative thought. As we rush headlong into the age of artificial intelligence, are we just trying to build faster, fancier tools that simulate understanding? Or are we going to do the hard, rigorous mathematical work required to build true cognitive architectures, systems capable of being actual, reliable partners for the future mind? Honestly, the difference between those two paths will define the entire next century of education. Thank you so much for joining me for this explainer, and as always, keep learning.